score. Yay? Okay, here we go. In a standardized normal distribution, standardized, meaning that the mean is always going to be the same. The mean will always be, right? And the standard deviation, the distance away from the mean, will always be 1. So when you standardize a normal distribution, the mean is always at 0. 0. Yeah, and then it's just one width for mean every single time. Okay? Okay. Okay. A z-score is the number of standard deviations away from that mean, so it's not going to be pretty. It's not going to always be 1, 2, 3. If something is exactly 1 standard deviation away from the mean, then you would have that 68, 95, 99.7 thing happening. But if you just want to know, like, what's 0.5 away from the mean, right? We use a z-score and the z-score table to find those not so pretty possibilities. Okay? Okay. Here we go. Now formula again. Z is equal to x minus mu divided by sigma, which stands for the standard deviation. Yeah? And then you read your probability from the z-score table. That's the whole step. Yeah? The z-score table will be given to you on the SOL on those little, like, study the tab on the right where it says test materials. You can find your z-score table. Alright, so it's not good. We're talking about this. I'll play that. Alright. Here we go. Alright. Let's practice finding the z-scores. In Mrs. Rich class, the scores on a test were normally distributed. The mean was 85, standard deviation 5, find the z-score. Joe got a 92. So, what's the target value? It's 92. What's mu? Yeah. And sigma is 5. So Joe's z-score is going to be 92 minus 85 divided by 5. Okay. Crunchy, crunchy. Shout it out. 1.4. Yeah. She got a 1.4 as a z-score. What's that mean? I don't know. Did it do bad? Did it good? What's the mean? 0. So is he above average or below average? He's above average. Hey! Go, Joe! Great! Yeah! Alright. On the same test, Sarah didn't study. Aww. She got 63. What's her z-score? Z is equal to 63 minus, what's it? 5 divided by 5. Stay trip. Below average. Way below average. I'm pretty sure she got the lowest one test because you don't want to go like 3 standard deviations away and she performed 3. So, yeah, it wasn't her thing. Right. Probably like rational functions. Alright. Here we go. SAT! P.S. This is how they figure out what percentile you got. Yeah. Alright. Here we go. Example 3. The distribution of the math SAT scores is normal. That's key. The mean is 500, standard deviation of 100. Brittany got a z-score of 1.8. What was her actual score? So what are we looking for? The x! So smart. Alright. The z-score is 1.8. Her actual score is x minus. Let's do. Add 100. Yeah. So if you solve this thing, 680 was her score of the SAT. Yay? ACT, completely different grade scale. Here we go. The mean is 18, standard deviation 6. Miranda got a z-score of -0.5. Actual score was, well, Negative 0.5 is equal to x minus 810 divided by 6. Solvey, pluggy. 15. Am I going too fast? Do you want to see all the steps? We're good. We're good? Okay. So it's 15? Yeah. It's below average. Gosh darn it, Miranda. Here we go. All right. Yeah. Yeah, it's a good thing. Okay. Here we go. If you're a visual person like me, drawing the graph is very important, right? So you know what you're looking for. If you're not visual and you can do it in your head, okay, that's fine, but I need to see it. Honestly. All right, here we go. Yeah. Okay. A z-score of less than 2.85. Okay? So this is 0, 1, 2, 3. Right? 2.85 is about here. It's true. Okay? If you're looking for the z-score that is less than 2.85, where? Less than. So left. True. Okay. So we're shading this. I know I didn't hand out highlighters. Does anyone want a highlighter? Good. Okay. You can shade with your pencil if you want to. But yeah. You're looking for that area, which is awesome. If you're looking for the left side of the z-score, you just read it off the chart. Here's how we do it. Okay? So you're on your z-score table. Okay? Now, if you haven't noticed, the left page is all the negative z-scores. Okay? The right page is all the positive z-scores. True? Okay. So you're looking for 2.85. So you scroll down till you go to 2.8. Woo! There it is. There's 2.8. And then you go to the 0.5. So 2.805 is right there. What is it? 0.9978. Yeah. So that means she has a 90. She's better than 99.78 of the student. True? Yeah. Yeah. So that's how you read a z-score table. It's so easy. It's so easy. Okay. All right. Here we go. So the percentage is 0.9978. Or you could write that as a percent. I'm going to go do this once. I'm not going to write percents anymore, okay? 99.78% is what that means. Okay? Okay. Only wrote as percent just in case you see that form on the SOL, but if you just write the decimal, I'll know what you're talking about. Just don't put percent after decimal. What if it's bigger than 2.85? Yeah? So here's 2.85 right here, and we're looking for the right side of that. Okay? Just that little piece. Question, what is the highest percent you could possibly have? 100. And what's 100 as the decimal? What? It's what? Point nothing, right? So, to find this thing, to find the right side, subtract this number from what? That's it. Yeah, yeah. So it's 1 minus 0.9978. To find from the right side, you subtract it from 1. Okay? Answer. 0.0022. Eight? Okay. Okay. Here we go. Next one. It's a negative. Oh, God. Negative. Yeah. Negative 1.66. So here's 0, 1, 2. So 1.66 is probably around here. And we're looking for z greater than that point. So left or right? Yeah. Yes. To the right, to the right. Okay? So that means we have to subtract our probability from 1. So it's 1 minus, read your z-score table, negative 1.66 is 0.04. I see 8.5. Are we good with 8.5? Yeah? Okay. So 0.0485. Take that away from 1. The probability is. Are we good? 9.5. What? 1.5. Yeah. Woohoo! Yellow. Oh, kind of read that? Okay, so you're in the negative side, so you're looking at the left part, right? Okay. So you need to find negative 1.6 first of all. Yeah? So you go to negative 1.6 and go all the way over to 6. Yay? Yay. Sweet. Okay. Okay. So the z-score, the right column, left column is only the first 2 numbers, and then you go to the last number in the column to go over. Yeah, so you can only go to 1.6 on the left column, and then go over to 0.06 to get that last digit. Because negative 1.6 plus 0.06 negative 1.6. Okay, so the side, the top column is like the hundredths place. Right? There's tens, hundreds, thousands. Got it. Because the 100th digit is. Oh. Yes. Okay. Yes. Yep. Yep. All right. Here we go. I think the other part got cut off on your notes. Is that right? Sorry about that. It's supposed to be less than 2.85. Is there? Okay. Good. All right. So here we go. Negative 1.66 is like right here. 2.85 is like 1, 2, 3 right here, right? Ah! Good. You're a genius. Big minus small. That's it. That's it. Right? Because on the table, we already got 2.85. What was it? 0.9. Is it 85? Is that right? At 2.85, we got 0.9985. True. Is it 7? Sorry. 7.8. Sorry. 9978. Woohoo! 0.9978. Yeah? And then at 1.66, we got 0.4085. Sorry. 0.485. Yay? Just reading it off the z table, you just take the score. You don't have to subtract it from 1 or anything. Okay? High minus low. There you go. Yeah? Alright, here we go. 0.9978 minus 0.04845 is 8.9493 is that. So in between, high minus low. It's so easy. It's so easy though. Yeah. What? Because you're looking on the right side. Right? If you're looking for the right side, just the right side, you have to subtract from 1. Because the z-score table only tells you the left side. Yay? Yay. What? Caitlin, did you say word problem? Oh! Here we go. Oh. Here we go. The length of human pregnancies from conception to birth varies according to a distribution that is approximate. With a mean of 266 days and a standard deviation of 16. What percent of pregnancies last less than 240 days? Okay. All right. to do this, we have to find the z-score, because it's not going to be a perfect, because if you're at 266 and you add 16 every time, you're not going to get to 240 very nicely. Yeah? Okay, so here's what you do. Okay, first find your z-score. What's my target? 240. So 240 minus the 266 over 16 gives me a z-score of negative 13. What was it? No, oh, decimal. Okay, so negative 1.63, just so we can find it on the z-score table, right? Because the z-score table only goes to the unders place. Okay, so around to the unders place. All right, so yes, sir. Huh? Sure. Did you go ahead? Or you good? Okay. All right. All right. We want pregnancies that last less than that. So we're looking for the z less than negative 1.63. Okay. So if you draw your table, negative 1.63 is right here. We're looking for the left side. That's what I'm sketching. Okay. So when you see that table, what do you do that number? Yeah, that's it. Just keep the number, right? Because you're looking at the left side. So when you find negative 1.63 on your z-score table, that's yeah, what is it? 0.516. That's it. 0.0516. That's it. Yay! It's so easy though. Yeah. Yes. There you go. Is there a different one? Yeah. Okay. Between 240 and 270. So we know this one from the previous example, we'll just call this Z1, has a z-score of negative 1.63. We did that in the last problem. All right, you need the second z-score because you're finding an in-between. So the second z-score is going to be 270 minus 266 divided by 16. What is it? 0.25. I like it. Okay. So if you were looking at this picture, you've got negative 1.63 and 0.25, which is right after 0. So 0.25. So you're looking for a between that. Okay? Okay. 0.163 we got already. That was 0.0516. What's 0.25? 0.5987. Okay? Now what? Thank you, love. So here's what I want you to consider. Yay? Okay. Use two different highlighters. All right. Here we go. Okay. 0.516 is this probability. True? Okay. 0.587 is this probability. It's already included this thing, so you need to subtract that. Big minus small. That's why, because yeah, Jenny was saying it was. So Jenny was saying it was after subtract 1 from 0.516, but then you would be looking at all this right side. So if you just did big minus small, then you would just cancel out where they go back in the first place, right? Yeah. No, there was. She was just thinking, it's so good. 5987 minus 0.0516. Yes. 0.5. What's that? What? Yeah. Ta-da! Okay. All right. Here we go. How long do the longest 20% of pregnancies last? Okay. Okay. It's not the z-score, it's the formula. So we'll define the z-score that has that percentage. Okay? Okay. Here's the deal. The longest 20%. I can see it. Draw a picture. Right? Here we go. If you're doing your z-score, your table, right? The longest 20% will be on the right side. What's on the left side? Yeah, 80% is on the left side. True? So, you're looking for as close to 0.8000 as possible. Because that would be percent. Okay? Okay. So we read our table. Okay. So read our table, and you're looking for as close to 0.800 as possible. So it looks like 0.7995 is really close, and then 0.0823, which one's the closest? This one. 0.7995 is closest. Do you see it? Yeah? So what's the z-score at 0.7995? 0.84. That's it. Yes, love. Well, that's the closest to 0.8000. Right? So you find the closest number that to 0.800, because that's what. Well, this is 0.8. The other closest one is 0.8. Is there a 0.800? Where? The very first column. Oh no, you're not. No, that's the z-score. That's the z-score. So you want to find the percent that's closest to 0.0888, 0.8, yeah. All right, and then you pull the z-score from there. So yeah, so 0.795 is only 5 away, right? 0.005 away. So the closest z-score is 0.84. Okay, so on your picture, right? That's your percent. Your z-score is 0.84. Okay? All right. Now let's work backwards. We'll look for our target value, x. Okay? So we know the z-score is 0.84 is equal to x minus 666 divided by 16. I'm going to put a little squiggly because I think yep, multiply by 16 and add 266. Yeah. So about 279 days. Yeah, about 279 days. Yeah! That's tough. No? Where? 0.84. Gotcha. Okay. Are you looking at your chart? Okay. So, according to this picture, I would draw this picture. I'll wait for you. The top 20% is on the right, which means the bottom half is the bottom 80%, right? Since the z-score only tells you the left side, you have to go with the number on the left side. Okay? 80% is 0.8000. So you're looking at your z-score and looking for the closest thing to 0.800, and the closest thing is 0.7795, because it's only like 0.0005 away. So you grab your z-score from that percentage, which is 0.85. Okay? You gotta go backwards from the percent to find the z-score. Alright, here we go. Almost there. Okay, yes. Alright, if you're looking for a nice, cush, very well paid job, it's called actuary. Actuaries read charts all the time. Just print up. So, like this. 6 figures? Come on. 6 figures? Actually, funny story. 6! Yeah. So my statistics teacher in high school actually gave up her six-figure actuary job for an actuary. And pay like little money. All right, here we go. It's all good. You know, it's a balance of life. Huh? Whatever makes you happy. Amen. Amen. All right. Last one. Once upon a time, a normally distributed set of 1,234 values has a mean of 112 and a standard deviation of 13. What is the number of values expected to be above 135? What are you looking for? Z-score. Z-score. Find your Z-score, then find your percent. Yeah? Okay. Here we go. So the 135 is your target. So 135 minus 12 over is equal to each. So 1.77. True. Well, I mean, you just need to round it to the hundreds so you can read off each one. Yeah? Okay. Okay. Draw a picture. Draw a picture. Yeah? Okay. 1.77 is about here. And we're looking for above. So shade to the right. Okay. So you read your Z-score table and find 1.77. Girl, you're good at this. You can be an actuary. 1.6. But that's not the number because we're shading to the right. So you got to subtract from 1. Exactly. So you go 1 minus 0.9616 is equal to what is it? 384. Does that answer the question? No. Right. It says what number of values? What is the number of values expected to be? How many numbers are there? 1, 2, 3, 4. And multiply it to 1, 2, 3, 4 because that's the percentage that's bigger than 135. But to find the number of values, you take the percent 0.384 times 1, 2, 3, 4. It's about 47 values. What's up? It's not well. It's not like exact, right? Is it? No, it's not. It's not. Yay! What's up? Say it again. I don't know. So like usually it's a multiple choice question. It'll say like what's it closest to, and then you just pick the answer. Right? Yeah. All right. Here we go. Take a look at the top of your notes. Yeah. Okay. So I got the good news. I got the bad news. Here we go. The bad news first. There's 38 of them outside of the hallway. The good news is odds do odds, evens do evens. All right? When you come back in, then start on the homework. It's at your own pace for the rest of the class. Let's go. Let's go. What? Did I just hear a whine? Oh, see.